Hello, in this video I'm gonna be solving this problem. So the question is, prove that the following subspace is supplementary in E. So we have two subspaces, so F and G, right? F is this set and G is this, and span 1, 1, 1. And you gotta prove that these two are supplementary. So before we prove that, you need to understand this. So if you want to prove that F and G, they're supplementary, you gotta show the two cases. The first one is F plus and G, it's a zero vector, and then the second case is F plus G is E in E. So they're both linear subspaces of E. In order to show the second case, you need to show for all W in E, there exists U in F and there exists U in G. There exists V in G, such that W is equal to U plus V. So U and V are unique. So this is the main idea. This is what we're gonna be doing in the next minutes. Okay. So there we go. So first we need to show that it's a zero vector, right? So first we need to show this step. So you always say that it's just like proving left to right and then right to left. So you say the inclusion is obvious, and the inclusion this. You need to write this on your answer sheet. Okay, so in order to prove this side, you say let's just say let U is F and G. And we're just saying we're just defining it, initializing it, and then you can say then because U is in G, right? From this we can decide that there exists lambda where U is equal to lambda lambda lambda. Why? Because where does it come from? It comes from here, because G is span 1, right? 1, 1, 1. That's why it's just like U is lambda times 1, 1, 1. So that's why. So we say U is equal to lambda, lambda, lambda. And also, at the same time, U is in F. I mean, from this, where's my red marker? So look, from this, first I got this one, and I come here. And I got this one again from this. I got this one. I mean, U is also in F. What does it mean? If U is in F, it means that, look, F is x, y, z, and then x minus 3y plus z equals 0. In our case, U is equal to lambda, lambda, lambda. That's why lambda minus 3 lambda plus lambda equals 0, right? So this is equal to minus lambda equals 0, lambda equals 0. If lambda is 0, then U is equal to 0, 0, 0, right? So what does it mean? It means that U is 0 vector. It means that we have proven this case. Okay, and now, alright, so now let's go to the next step. So in the next step, we need to check this case. So before I start solving, let me focus the video one more time. Okay, now you can see it. Cool. So again, in the second step, you need to show that E is equal to F plus G. And you say the inclusion this. It's just like proving left to right and then right to left. This is obvious. And then the inclusion this. You need to show this case. So in here, we say let W is equal to, let's just say x, y, z, right? And this is in E. And now we look for U is equal to A, B, C in F. Because it's in F, we can easily conclude that A minus 3B plus C equals 0 from this x minus 3y plus z equals 0. And V is lambda, lambda, lambda. It's span 1, 1, 1, and it's G. Okay. And now, such that we gotta look, we define w, and then we need to look for u and v, such that, let me write it in order to explain it for you. U plus v. Okay, we need to, right now we define u and v, and then we need to find u and v, such as u plus v is equal to w. And what is w? It's w is x, y, z, right? And what is u? U is a, b, c. What is v? V is lambda, 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 right? And from this you can easily get that, okay, you can easily get that a, b, c is equal to x minus lambda, y minus lambda, z minus lambda. Okay, and now from this I can get this one. Look, I have this condition, right? A minus 3b plus c, it's equal to 0. I know this. That's why in here, because I have a, b, c is this one. A is, what is a? X minus lambda minus 3. What is b? Y minus lambda. I'm just inserting the values. And c is equal to plus c. What is c? Z minus lambda, right? And this is 0, and this is equal to x minus 3y plus z plus lambda. So lambda is equal to minus x minus 3y plus z. Okay, now I found the one particular solution, one solution, and now all you gotta do is you just have to write it down here. So u is a, b, c, right? A, b, c. So a, b, c is x minus lambda. What is lambda? Minus this, so it will be plus x minus 3y plus z. So I'm getting this from here. So a, b, c, I'm getting it from here. Okay, just for explanation. And now b, what is b? B is y minus lambda, so y plus, because of this minus it will be plus x minus 3y plus z. And then c is equal to z minus, it will be plus again, z minus lambda, x minus 3y plus z. So this is u now. And what is v? V is equal to lambda times 1, 1, 1, or minus x minus 3y plus z times 1, 1, 1. Right, in our case. So we found the solutions, but this is not where you stop. This is actually like this is something. Look, from here to here. It's something that you should be doing on your draft. I mean, you don't really need to write this on your answer sheet on the exam, according to my professor, Professor Uvra. So you don't need to write this on your exam. So what do you write then? So again, you open the next not the next page, just same thing. Look, it's just same thing. This side is obvious, and here what you need to write is, right now let's just say, let me focus the video first. Okay, so the coordinates for u, right? For u and v. So I'm gonna be, so okay, now you can see it. Okay, cool. So in here you say let u is equal to x plus, you just copy this one from your draft, x minus 3y plus z, y plus x minus 3y plus z, and z plus x minus 3y plus z, right? So this is u, and this is in F. You need to prove it. I mean, this is in F because x plus x minus 3y plus z. What is F? In this case, look, F, if x, y, z, this one must be 0. So you have so minus 3 plus z, let's say this must be 0, right? So minus minus 3 what is y? Y is this, y plus x minus 3y plus z plus I'm gonna write it here, z plus x minus 3y plus z. So this is equal to 0. Why? Because look, first I take x. Look, let me explain. First I take this one, and this one, and then I take this one, and this one. So if you take this as this, it's x plus, no, x minus, this is minus, guys, 3y plus z. So you have x minus 3y plus z. If you say this is lambda, so you have minus lambda, which is minus 3y plus z. So this is obviously 0, right? So right now you showed that u is this, and it's in fy because if you calculate this, it's equal to 0. Where did I get this? I got this from here. And now you say v is equal to, let's just say minus x plus 3y plus z 1 1 1. It's in G. You don't have to show this because 1 1 1 it means span 1. And now then w is equal to, let's just say x y z, where w is u plus v. So not f, w is in f plus g. Okay, so what you do is, like, first on your draft you found u and v, and then here on your answer sheet you just have to show that u and v exist. Just one example would be okay, like this and this exist, and as long as you can show this, it's okay. But here this part is important, like, because like proving it, like, because u is in f, you gotta prove this one. This is important, and this is cool. Okay, so this was quite long, and now before finishing it, let's recap. So again, you are going to have a question, like you'll be given a set like this, linear subspace of E, and now you gotta prove the supplementary. First step is you gotta show that this is 0 vector, and or it's this, and you always say this case is evident and the inclusion this, and you say let u is f and g, and and then you gotta show that u is 0 0 0, and then u is 0 vector. And in the step 2, you gotta show that f plus g is equal to e. In order to show that, you say again this is evident, and then the inclusion this, let w is e, and you gotta find u in f and v in g such that u is equal to, no, w is equal to u plus v. Alright, that's it for this video. I'll see you in the next video. Bye bye.